Alright, let's look at the homework 4.4, problem number 4. Alright, so we want to sketch the graph of f of x equals 6x over x squared minus 16. Alright, so let's do that. Alright, first one, we want to find the domain. Alright, so if you want to find the domain, we have to make sure that, in this case, denominator is non-zero. Right, so from there we can factor out. So x squared minus 16 is 4 squared, so we can write it as x plus 4 times x minus 4. Right, so we don't want these guys to be 0. Right, so which means that the domain is going to be all real numbers except positive and the negative 4. Right, so let's type it in. Right, so it's going to be all real numbers. So here, this is the one. Right, so check the answer. Right, we got the domain. Alright, then we want to find the x-intercepts and the y-intercepts. So let's find that. So if you want to find, say, y-intercept, we're going to set x equals 0. Right? So basically you just plug in 0 into that function. Alright, so it's going to be 6 times 0, so 0 of anything is 0, so it's going to be 0. Alright, then x-intercept, we're going to set y equal to 0, so which means that we set the function, which is f of x is equal to 6x over x squared minus 16 equal to 0. But we can just set the numerator equal to 0, so 6x equal to 0. By dividing through by 6, we know that x equals 0. Alright, so looks like x-intercept is 0 as well. So plug it in. So x-intercept 0, y-intercept is 0, so that's that. Alright, we got this one. Alright, then horizontal asymptote and the vertical asymptotes. Alright, so we know that when x equals positive 4 and negative 4, this is going to be undefined, and a numerator is non-zero. So this tells you that the vertical asymptote is actually x equals negative 4, and also x equals positive 4. Alright, so in order to find the horizontal asymptote, we need to take the limit of this function, 6x over x squared minus 16, as x approaches infinity. Right, or it could be negative infinity. It's really doesn't matter. Alright, so in order to evaluate that, what you can do is, we just learned L'Hopital's rule, so let's try this. Alright, so since if you plug in infinity, denominator infinity squared minus 16 is going to infinity. Alright, 6 times infinity is going to go to infinity as well. So infinity over infinity, so we can take the derivative, apply L'Hopital's rule here. So x approaches infinity. Derivative of 6x is 6. Derivative of x squared minus 16 is 2x. Right? Then as x approaches infinity, so this guy goes to infinity. Right? So 6 divided by a huge number is going to approach 0. Right? So which means that the horizontal asymptote is y equals 0. Right, so we have that. Vertical asymptote, horizontal is y equal to 0. Vertical asymptote is positive 4, and x equals negative 4. Right, so we got that. Alright, so summarize. Let's see. We're looking at the first derivative, so we're going to look at the decreasing, increasing behavior. Alright, so derivative. So if you find the derivative of f, we're gonna get, right? So we need to square the bottom. So you have x squared minus 16 squared. All right, I'm gonna put the 6 right in front. Right, so derivative of x is 1 times the bottom, so x squared minus 16 minus x on top, and then the derivative of the bottom, which is going to be 2x. Alright, so we're going to get, this is going to be, let's see, the negative 2x squared and x squared. So negative x squared minus 16. So it's going to be negative 6. And you have x squared plus 16. And then you have x squared minus 16 squared. Alright, so we can see that here, because of the square, the denominator is positive. X squared plus 16 is always positive with the negative sign. So we know that this is negative. Right? So which means that it's always decreasing. Alright, so it's always decreasing. So here. So it's decreasing on, so we have to eliminate negative 4. So this is it. So f is decreasing on negative infinity to negative 4, negative 4 to 4, and 4 to infinity. So that would be the right answer. Right? So we got that. Alright, then let's see, since this is always decreasing, there is no local extrema. Right, so we have that. Alright, then we're going to look at the second derivative. So let's find the second derivative. Alright, so f double prime of x is equal to, alright, so we put negative 6, just a constant. And then I'm going to square the bottom. So you have x squared minus 16 to the 4th power, right? Then derivative of the top is 2x times the bottom, so it's a quantity x squared minus 16 squared minus top is x squared plus 16, right? Times the derivative of the bottom, which is 2, keep the same quantity, subtract 1 from the power, then multiply by derivative inside, so it's a 2x. Right, so we have that. Alright, so let's factor factor things out. So you have 2x here, and there's a 2x there. So we can turn this into, there's negative 6, so negative 12 x. Alright. Then also we have x squared minus 16, then actually 2 of those. So we put x squared minus 16. Alright, then what's left is, so there's going to be another x squared minus 16. And here it's minus 2x squared and minus 2, so it's a 32. Right, so then you have over x squared minus 16 to the 4th power. Right, so we can cancel x squared minus 16 and change that to 3rd power. And here I'm going to, so this is going to be the same as, so negative x squared minus 48. Right? So we can combine with this negative sign here. I can turn this into a positive. So this is going to be, right, so x should be there. That's cancel out. Now we have x squared plus 48. And over x squared minus 16 cubed. All right. Then we need to analyze this. So I'm going to use a number line here. All right. Then we need to put, let's see, negative 4 and a positive 4. All right. Also, the second derivative becomes 0 when x equals 0. So we put that 0 here. All right. Then look at the sign. So f double prime. Alright, try any sample number less than negative 4, x equals negative 5. Between negative 4 and 0, so x equals, say, negative 1. And between 0 and 4, x equals 1. Greater than 4, x equals 5. Alright, so if you put negative 5 here, so that's going to be positive on the bottom. Negative here, this is always positive, so we know that the sign is always negative here. Alright, if you plug in negative 1, negative, positive, that's going to be negative cubed, so it's going to be positive. Alright, if you do positive 1, positive, positive, that would be negative. If you put 5, that's positive, that's going to be positive, so everything is positive. Right, so it's going to be, original function is going to be concave down on interval negative infinity to negative 4. Between negative 4 and 0, it's concave upward. And between 0 and 4, concave downward. And after 4, concave upward. Alright, so let's look at that. Alright. So it's going to be concave upward on, let's see, negative infinity to 0. So let's go back. All right, concave up on between 4 and negative 4 and 0, and a 4 and up. So let's see if we can find those. Concave upward, let's see, that's not going to be it. Concave upward, not there. Concave down. And a negative 4 and 0, 4 and up. So looks like this is it, right? All right, concave down, infinity, and 0 to 4. So looks like it fits this description. So let's double check. Check the answer. All right, we got that. All right, inflection points. You can see that the concavity changes. Right, but you cannot have an inflection point if the function is not defined there. So negative 4 and positive 4, you would not have it. So only inflection point you can find it would be right here. So inflection point. So this is going to be at 0. Right, so inflection point is going to be at 0. All right, so we got that. All right, now sketch the graph. Choose the correct answer below. So we know that here, this guy is always decreasing, and start out with the concave down, up, down, up. So let's look at the picture. All right, always decreasing. This is not it. This is always increasing. This is not it. This is always decreasing. You have a concave down, concave up, concave down, concave up. So this got to be it. All right, check the answer. We got that. All right, that's it. I hope that this was clear.